everyone, this is Ms. Drake. In this lesson, we're going to be looking at quadratic equation applications and projectile motion. So if you're in my class, we're on page 17 in the second booklet, the Unit 6 booklet. Okay, so we're going to be looking at example 1. The first thing we're going to do is read the question. A cliff diver on a Caribbean island jumps from a height of 105 feet with an initial upward velocity of 5 feet per second. An equation that models the height, h of t, above the water in feet of the diver in time elapsed, t, in seconds is, and on your copy this little 2 should be an exponent, I just had to handwrite it, so it's h of t equals negative 16 t squared plus 5t plus 105. So I'll rewrite that down here. H of t equals negative 16 t squared plus 5t plus 105. Okay, you should rewrite it also since we're going to be working with the equation. So the question is, how many seconds to the nearest hundredth does it take for the diver to fall 45 feet below his starting point? Okay. So the reason this has to do with quadratic equations and the quadratic formula is we have a little picture over here of a man jumping off a cliff or diving off a cliff, and you can kind of see he jumps up, and when he dives down into the water it makes this parabolic shape, and the equation of a parabola is a quadratic equation. Okay, so it's going to have a negative a because it's an upside down frown, and this is the formula that represents the shape of his dive. Okay, so we need to solve this equation, but they're going to tell us what we need to solve for. So let's go back to the question. There's an initial height of 105 feet. So you can kind of see in the equation, this 105 here, that constant at the end always represents the initial height. Now this upward velocity of 5 feet is going to be this middle term here, this b, and then the negative 16 in front of the t squared, either that number or negative 4.9 will show up a lot because that's the force of gravity pulling the object, the person, the rocket, whatever we're talking about, down. So we want to know how many seconds, which means we're solving for a t value. So we want to know t equals what when the diver is 45 feet below his starting point. Well, what was his starting point? His starting point was 105 feet. So what would 45 feet below that be? Well, what is 105 minus 45 is equal to 60 feet. So we want to know when he's going to reach 60 feet. So this is an h value, which means I'm going to plug in 60 for h, and then I can solve the equation once I just have one variable. So let me go ahead and put the number 60 here underneath where I wrote h, and then I'll rewrite the rest of the equations. If you didn't rewrite it before when I rewrote it, you should rewrite it now. Okay. So now we have a quadratic equation, and you've learned multiple ways to solve quadratic equations, but for most of them you're going to get them set equal to 0. So typically you might put the equal 60 on this side, but I'm going to get it equal to 0 on this side, and then we'll just kind of flip where the 0 is. So I'm going to subtract 60 from both sides, and that way this is equal to 0, and I have negative 16t squared plus 5t plus 45. Okay, so again, you're used to seeing it the other way, where it's negative 16t squared plus 5t plus 45 equals 0. So I'm just going to put the 0 on the other side. Now this is a t because we're using t for time, and this was an h because we're using h for height, but it's the same as x here and y here. So we want to solve for t. Okay, since my a value is greater than 1, I think the best way to solve will be using the quadratic formula. Okay, so I'm going to rewrite my quadratic formula here. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay, so now I'm going to plug in my values for a, b, and c. So a is negative 16. b is this middle number 5, and c is my constant 45. Okay, so I'm going to go ahead and just substitute. So negative b will be negative 5, and then plus and minus. I have a big square root sign, b squared, so 5 squared, minus 4 times a is negative 16, times c is 45, all over, oh, I hope we can fit this, 2 times a, which is negative 16. Okay, and sorry, my fraction bar should have gone a little longer. The nice thing is, once you have the formula written out, we can just go straight to our calculator and plug in those numbers. So I'm going to bring up Desmos. Okay. And if you go to the scientific calculator, we're just going to go on in this screen, and it's one giant fraction. So you press this fraction bar and you type in your numbers. We have negative 5 plus square root 5 squared minus 4 times negative 16 times 45, and then that's all over 2 times negative 16. Okay? So when you press enter, or you don't even have to press enter, it just shows up, you have negative 1.528. So I'm going to just write that here as one of my x values, but it's really a t value. I wrote x. So t equals negative 1.528 dot, 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 dot. Okay. Now I still have to do the same thing with a minus sign, so let me go back to Desmos. And the nice thing is I can just highlight that and change it to a minus, and it will give me the other one, 1.8405, blah, blah, blah. All right, so let me write that down. T equals 1.8504, dot, dot, dot. Okay, so only one of these two can be the answer, can be the correct answer. So when we're talking about time, the initial time is always 0, so you always want to reject the negative number because it wouldn't make any sense for him to fall negative 1.5 seconds after he started. So this one has to be the correct answer, 1.8405. And if you look at your answer choices, oh, it asks us to round to the nearest hundredth. So it would be this place value right here. Okay, remember, look to the right. 5 or more, raise the score. 4 or less, give it a rest. So I'm going to let this rest at 1.84 seconds. So that would be answer choice 2. All right, let's take a look at example 2. This one is a little bit faster. Let's see. The expression negative 4.9t squared plus 50t plus 2 represents the height, so this is an h equals, just like the other one was, in meters of a toy rocket, t seconds. So again, t stands for time again, and h would stand for height after launch. The initial height of the rocket in meters is. Okay, so I'm going to highlight the word initial. So when we talk about initial height, we're talking about on your table when either x or t is equal to 0, we want to know the height. So there's 2 ways you could do this. Since you know t is 0, you could substitute 0 in for t to find the height. Or you could put the equation into your y equals on your calculator and figure out the h value when t is 0. So I'm going to use the substitution method, but either one would work. I'm going to substitute t equals 0 into this expression. So negative 4.9 times 0 squared plus 50 times 0 plus 2. Okay, and when you evaluate this entire thing, you plug it into your calculator in Desmos, you should get 2. Okay, so that would be answer choice 2 again. Okay, I crossed off number 3 because I ended up taking it out of your packet, so I'm going to turn the page, but your next question, number 3, is my number 4. Okay. Let's see. A drone is shot vertically in the air. Its height, h, at any time t in seconds can be modeled by this equation. Determine algebraically the number of seconds it would take for the drone to reach a height of 529 feet. Okay, so remember, the reason we're using this quadratic formula is when the drone is shot up, it's going to make this parabolic motion. So it's going to come up, it's going to come down. We want to know when it reaches this height. So ultimately, we just want to know when h is equal to 529. So we're going to substitute that for h into my formula. So I'm going to rewrite this formula. I put in place of the letter h, I'm going to write 529. So I have 529 equals negative 16t squared plus 184t. Okay. So quadratic equation again, I want to get it set equal to 0. So I'm going to minus 529 on both sides. Okay, so I have 0 equals negative 16t squared plus 184t minus 529. Okay. Now I'm going to use my quadratic formula again. So x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. All right, let's plug in our values. B is 184, so negative 184 plus and minus 184 squared minus 4 times a, which is negative 16, times c, which is negative 529, all over 2 times a, which is negative 16. At this point, you should pause the video. I'm not going to show you how to do it on Desmos again. You pause the video, type this answer into Desmos, and let me know what you get. Okay, hopefully when you typed it in, you got 23 over 4, or when you converted it to a decimal, you got 5.75. Now, both times that you did it, the plus and the minus, you got 5.75 as both answers. So since there's only one solution, you know that's the correct answer. So we have t equals 5.75 seconds, right? They want to know the number of seconds it will take for the drone to reach that height. Okay, one more. They're all a little bit different. That's why we're doing so many of them in this video. Let's see. Example 5, which would be your example 4. When a Pokeball is dropped from a tower 256 feet high, the function h of t equals negative 16t squared plus 256 models the height of the ball in feet after t seconds. So again, we're comparing height and seconds as our x and our y. Determine algebraically the number of seconds it takes for the ball to hit the ground. Okay. So in the last few, we knew what height we were looking for, and we plugged those numbers in for h. But they don't give me a number for h. I have to figure out what number they're looking for. When a ball hits the ground, again, let's picture that parabolic motion. We're dropped from a tower. When it hits the ground, what is the height? 0. So we're plugging in 0 for h. I'm going to rewrite my equation, and in place of h, I'm going to write the number 0. Well, the good thing is my equation's already solved for 0, so I can go straight to my formula or preferred method of solving. Okay. The only thing that's a little bit different about this one, once I use the formula, is you have to be careful about your a, b, and c since there's only 2 terms. A is negative 16, b is 0, and c is 256. Okay. At this point, you should be able to plug into the formula and solve, so I'll let you pause the video and do that, and then I'll show you the answer. Once you plug your numbers into the formula, you should have gotten x is negative 4 and x is 4. Since we can't have a negative number of seconds, your answer would be 4, so 4 seconds. Okay, let us know if you have any questions and try the homework questions attached.